Directions: read the following information about what can be learned from ice cores and answer the questions in the Google Forms assignment. Nature's time machine. How would you like to have a time machine that could take you back anywhere over the past 300,000 years? You could see what the world was like when ice sheets 1,000 feet thick blanketed Canada and northern Europe, or when the Indonesian volcano Toba blew its top in the largest volcanic eruption of the last 500,000 years. Well, scientists have such a time machine. It's called an ice core. Scientists collect ice cores by driving a hollow tube deep into the miles-thick ice sheets of Antarctica and Greenland, and in glaciers elsewhere. The long cylinders of ancient ice that they retrieve provide a dazzlingly detailed record of what was happening in the world over the past several ice ages. That's because each layer of ice in a core corresponds to a single year, or sometimes even a single season, and most everything that fell in the snow that year remains behind, including wind-blown dust, ash, atmospheric gases, and even radioactivity. Indeed, the fallout from the Chernobyl nuclear accident has turned up in ice cores, as has dust from violent desert storms countless millennia ago. Collectively, these frozen archives give scientists unprecedented views of global climate over the eons. More importantly, the records allow researchers to predict the impact of significant events, from volcanic eruptions to global warming, that could strike us today. 160,000 years before the present. Global warming. Many scientists fear that rising levels of so-called greenhouse gases from the burning of fossil fuels and other human activities will cause global warming, with potentially grave consequences for human agriculture and society. One of the clearest signs that elevated levels of greenhouse gases can result in warming comes from an ice core taken near the Russian Vostok station in Antarctica. This graph tracks temperature and atmospheric levels of carbon dioxide, CO2, and methane, CH4, from the present back to about 160,000 years ago. This represents about 11,350 feet of ice accumulation. The graph clearly shows how a rise in gases will mean a rise in global temperature, though whether rising gases trigger rising temperatures or vice versa, remains unknown. Also note that, though the graph, which has data up to 2 decades old, does not show this, at about 360 parts per million, the amount of CO2 in the atmosphere today far exceeds levels at any time in the past 160,000 years, indeed, in the past few million years. For those worried about global warming, this is a sobering statistic. 73,000 years before the present volcanic eruptions. Approximately 73,000 years ago, an Indonesian volcano known as Toba erupted with enough force to send more than 600 cubic miles of volcanic material into the atmosphere. Detected on this graph, which displays volcanic sulfate levels between 20,000 and 110,000 years ago, Toba was the largest eruption of the past 500,000 years. The seemingly larger spike at about 53,000 years ago involved a series of smaller eruptions on Iceland, which is far closer than Toba is to Greenland, where this core was taken. Such violent, so-called caldera eruptions can drastically alter global climate by spewing so much ash and sulfur compounds into the atmosphere as to block sunlight and lower temperatures worldwide. Ice cores offer scientists the best means available to learn how past eruptions have affected climate, and thus to predict the impact that future ones might have. If an eruption on the order of Toba, which climatologists believe may have led to as much as several centuries of cold climatic conditions, were to occur today, it could seriously disrupt life on Earth.